Welcome students, हम डिस्कस कर रहे हैं the first numerical from the exercise for the chapter mechanical properties of solids. So let's start. The question says calculate the coefficient of static friction for an object of mass 50 kilograms such that when the object is placed on the horizontal table and pulled by attaching a spring balance to it, the force is increased gradually, and it is observed that the object just starts to move when the spring balance shows a reading of 50 newtons. So this is what is happening. So let me draw a quick diagram. So हमारे पास एक horizontal surface है and the nature of this surface is rough, meaning friction is at play. And on this surface we have our object resting, and this object has some mass, and I represent that mass using the small m. Now what we are doing is we are trying to attach a force, or we are trying to pull this object using some force. But this force is not directly applied onto the object, but rather it is applied to a spring balance, and then that spring balance is connected to an object. So हमें spring balance पे यहाँ पर उस force की हमेशा reading दिखेगा. So as we have been said that this force is of variable in nature, meaning the value of force will gradually increase, and this increase is reflected in the reading of spring balance as well. Now when the force is applied on the object on a particular side, since our table is rough, it will also apply a counter force due to the static friction, because it has a coefficient of static friction, and frictional force will try to oppose this force. Now, as long as my Fs, that is static friction ka value, is counter or balanced by external force, our object won't move. But the moment हमारे force का value exceeds the maximum value of our static friction, we'll see that our object is now moving towards the direction of the force. And we see a slight movement of object in the direction of force when our spring balance shows the reading of 50 Newton, meaning that the value of applied force is 50 Newton when the static friction ka value is maximum. Beyond this, static friction cannot increase any further. So the maximum value, so this gives us our first given data, that is the maximum value of static friction, and we write it as limiting force of static friction, that is FL, is said to be 50 Newton. इसके अलावा एक simple data और दिया है, that is the mass of the object. So small m is said to be 50 kilograms, and we assume the value of acceleration due to gravity, that is small g, as 9.8 meters per second square, as that is the most common value. Now using all this data, हमें पूछा है to calculate the coefficient of static friction, and we represent coefficient of static friction using the symbol mu s. So mu s is what we have to find. Now we have a pretty simple formula to calculate the mu s. Mu s, that is coefficient of static friction, is defined as limiting force divided by the normal reaction. Now since my object is resting on a horizontal surface, normal reaction is simply mass into acceleration. ठीक है? So इससे we get a slightly updated formula for our mu s, that is FL upon m times g. Now if we see, हमारे formula के सारे terms हमें already given section में available है. Now a simple substitution will fetch us the value for coefficient of static friction. So in calculation, I say from formula 1, we get the value for the coefficient. So from formula 1, I can say mu s is equal to the value of FL, which is 50 Newton, divided by the mass ka value, that is 50 kilograms, into 9.8 as well. And now if we were to solve this further, first things first, what we can do is we can cancel out 50 and 50 from the numerator and the denominator, and now we are left with the term 1 divided by 9.8. Now in your college exams or your college classworks, you'll have to use logs to perform this calculations, but in the video, for ease of calculation, we'll skip this step and directly arrive at the answer. And if you were to divide 1 by 9.8, you get the answer as 0.102. And this is the value of our coefficient of static friction, which is a unitless quantity. And that's it. If you want the PDF of the solution, make sure to check the link given in the description. Have a nice day.